Hello everyone. In this question, we will find Thevenin's equivalent network at terminal AB. As the Thevenin equivalent requires Thevenin's voltage VTh and Thevenin's equivalent resistance RTh. Let's see. This is our Thevenin's equivalent where VTh in series with resistance RTh. VTh is open circuit voltage of terminal AB and RTh is equivalent resistance looking back to the terminal while all the independent sources are replaced by their internal resistances. So here in this circuit, first we see the open terminal voltage. In this particular network, we can see there are many sources that are voltage sources and current sources. Here we can equalize this particular network by using source transformation. If we use source transformation, then without any calculations, we can drive the equivalent of this particular network. Let's see. First, we analyze voltage sources. Here, there is 8-volt source connected in series with 2 ohm resistor. So, by using source transformation, we can transform it into a current source in parallel with resistance. Similarly, we can transform this 2-volt source in a current source in parallel with resistance. Let's see. This is the concept of source transformation, where current source in parallel with resistance can be transformed by voltage source in series with resistance, vice versa, where the voltage value is I into R, or you can say the current value is V by R. So in this particular network, we will transform this voltage source in series with resistance. Now see the values. It's 4 ampere current source in the direction of 8-volt battery plus minus, and parallel resistance 2 ohm. And here this 2 volt in series with 3 ohm, its value of transform current source is 2 by 3 ampere in parallel with 3 ohm. These are the transformation. Now we will add these two current sources algebraically. So here both the directions are opposite, so net resultant source will be the 4 minus 3, that is 1 ampere in 4 ampere direction, and these two sources are in same direction, so it will be 2 by 3 plus 5, one current source in the same direction. Let's see the equivalent. This is the equivalent. This 4 minus 3, 1 ampere in direction of 4 ampere in parallel with 2 ohm, and this 2 by 3 plus 5, that is 17 by 3 ampere in parallel with 3 ohm, and this is our remaining network. Now here we will see there are current sources in parallel with resistances, so we can transform these sources by source transformation in as voltage source in series with resistance. Let's see. This is the equivalent as we transform all these current sources in voltage sources by source transformation. This 1 ampere in parallel with 2 ohm in transform in voltage source in series resistance. Voltage source value V is I into R, that is 2 volt in series with 2 ohm. And here 17 by 3 into 3, that is 17 volt voltage in series with 3 ohm. This is 6 volt. And this current source in parallel with resistance, its voltage value is 5 into 5, 25 volt in series with 5 ohm. Now here we can see There are multiple voltage sources connected in series, so we can make the equivalent for this lower branch. Let's see. For making the equivalent, 17 volt and 6 volt are in same polarity. It means 17 plus 6, that is 23 volt, and this 25 volt in opposite polarity, so these two will be subtracted. So 25 minus 23, that is 2 volt. Let's see. This is the equivalent, that is 2 volt in series with 2 ohm, and this all the voltage sources are connected in series, that is 25 minus 23, 2 volt, and 5 ohm plus 3 ohm is connected in series, so 5 plus 3 are 8 ohm. Now we will transform these voltage sources in current source in parallel with resistance for making the equivalent. Now this is our step 5. We will transform these voltage sources in current sources, that is 1 ampere in parallel with 2 ohm, and it's V by R, that is 1 by 4 ampere in parallel with 8 ohm. Now we add these two current sources and make the parallel combinations of these 2 ohm and 8 ohm. Its value is 5 by 4 ampere and 8 by 5 ohm. Now transform this in a voltage source in series resistance. It will give our total Thevenin equivalent. Let's see. This is our Thevenin equivalent. Here we get voltage source value is 2 volt and equivalent resistance is 8 by 5 ohm. So this is the concept for this type of network. Thank you. Thank you for watching the concept. Please like and subscribe my channel.